Okay. All right, one thing that you probably weren't aware of is that all these things that we've been studying, the ellipse, the hyperbola, the parabola, can be rotated. And when I say they can be rotated, I mean that instead of drawing an ellipse like this, we could actually have an ellipse that looked like that. Now, how does that idea manifest itself in an equation? You've been wondering that, haven't you?
Yes.
If you have a conic equation, or an equation, a second degree equation, that contains an xy term. So for example, here's one. If I covered this up, we've had equations like this before. In fact, if I covered that up, you could tell me what kind of equation that is. Is it a circle, a hyperbola, a parabola, or an ellipse? Can you remember?
I'm thinking ellipse.
You're thinking right. It's an ellipse. How do we know it's an ellipse? Well, first of all, there are two squared terms. That rules out parabola, because parabola only has one. Second of all, they are added together. That rules out hyperbola, because in a hyperbola they are subtracted. This is a 3x squared, and that's a 1y squared. When those numbers don't match, you have an ellipse. If they were both 3's or both 1's, it would be a circle. Okay, so that's kind of a quick reminder of what you already know. As soon as I throw in this xy term, all that changes. All those rules that you know are gone. I have no idea what this curve is until I evaluate its discriminant. You've heard that word before. What's the discriminant?
Negative b over 2a.
No. That's how you find the axis of symmetry of a parabola, but you're close. You're at least in the right chapter. You're in the right ballpark. B squared minus 4ac. Remember your quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a?
Yeah.
It's the part under the radical. The discriminant is b squared minus 4ac. Now, clearly this is not a plain little quadratic equation. So what are we talking about in terms of a, b, and c? A is the coefficient on x squared. B is the coefficient on xy. C is the coefficient on y squared. Now, if we needed a D, E, and F, we have them, but of course they're not part of the discriminant. A is the coefficient on x squared. B is the coefficient on xy, C is the coefficient on y squared. As soon as you have an xy term in your problem, it means you have a rotation. It means the axes have been rotated. And it means the only way to tell what you have is to do the discriminant. So let's do the discriminant here. B squared would be 16 minus 4 times A times C. I got 4. Did you when you evaluated that discriminant? That's a positive number. When the discriminant is positive, you have a hyperbola. So on your test, there will be a section, which will probably be next Tuesday. There will be a section where it just says, here's an equation, tell me what it is. You'll do the discriminant, b squared minus 4ac. If it comes out positive, we have a hyperbola. All right, let's try another one. What is it? No idea. Let's do the discriminant. B squared minus 4AC. Well, I don't even care really what that is. Can you see it's going to be negative? And when the discriminant turns out negative, you have an ellipse. So if the discriminant is a positive number, you have a hyperbola. If it's a negative number, you have an ellipse. Again, the minute you see this, you guys, you have got to do the discriminant. I have no idea what shape this is. There's no way to look at it and tell. We're going to do the discriminant. B squared minus 4AC. Oops, what happens this time? It's 0. Any guess what you got when it's 0?
A circle.
Nope, it's a parabola. Now, I heard somebody say circle. Circles are not part of this conversation. Can somebody tell me why, when I'm dealing with rotations, circles are not part of the conversation? Circles can't be rotated. Well, they can be, but what happens when you rotate a circle? Nothing changes, right? So we only talk about hyperbolas, ellipses, and parabolas. Okay, everybody clear on the rules? Tom?
So when the discriminant's positive, it's a hyperbola?
Yep. If the discriminant's positive, we have a hyperbola, negative an ellipse, and 0 is a parabola. Now, I'm going to caution you, in your homework and certainly on your test, I'm going to trick you. For example, what if this is the equation? Can you see how easy it is to get sucked into this? What is A in this equation right here? What's A? 3. What's B? Negative 4. What's C? 0. What is C? The coefficient on y squared. If there's no y squared, then C is 0. Similarly, if there's no x squared, A is 0. Right? Now, what else are you going to have to be able to do with these things? Not much. I'm going to ask you to identify the curve. Well, we've talked about that. How do we identify the curve? We evaluate the discriminant, right? Okay. What else? Well, there's only one rotation. These can get a little complicated, but there's only one that I'm going to have you do, and it is not complicated. We are going to deal with the most simple of all rotations, and that would be this. Now, how do I know that's a rotation? It's got an xy term. Anything with an xy term is going to have a rotation in it. Any idea what this looks like? You actually already know this, but it looks different than it did when we talked about it before. What if I wrote it this way? Does that ring any bells?
Looks like a sign.
It's one of your BFFs. It's the reciprocal function. Now, it's got a 9 in there, so there's a little bit of alteration to it. But you remember what the reciprocal function looks like when you graph it? It has an asymptote here and an asymptote here. And it looks like this. So in other words, this equation is a rotated hyperbola. Now, does it make sense to you, when you look at this equation, that there's no way x can be 0 and there's no way y can be 0? Does that make sense to you? Well, yeah, because if these were 0, you wouldn't get 9, would you? So they can't be 0. That's why you have asymptotes there. Any idea where the vertices of this hyperbola might be? This equation right here. Any idea where the vertices might be? If you guess, you'll get it right.
3.
3, 3. And -3, -3? Any idea where the center is?
0.
The origin.
0.
Center is at the origin. This would be your transverse axis. Would everybody agree with that? I'm going to tell you what the foci are, and then I'm going to ask you to maybe kind of make a connection and explain that to me. The foci would be at 3√2, comma 3√2, and at -3√2, -3√2. Now, can anybody kind of process that or somehow make sense of that or think of a way to help us remember that? Come on, what's your problem solving?
√9 minus √x.
It might be like a 45
What do you
degree
think
angle.
that, what?
It's a 45-degree angle.
It's a 45-degree angle. That right there is a 45-degree angle. And what do we know about 45, 45, 90 triangles?
That it's squared.
The sides are in the ratio 1, 1, √2. That's where that √2 comes from.
It's about this point.
That's where that √2 comes from. Okay, so let's see. For this kind of hyperbola, I will ask you for the center, the vertices, the foci, and the asymptotes. All right, so let's practice another one. Some of you are looking a little dazed. Let's try to focus. Okay, now I've tricked you. I put a negative in there. What do you think that will do? Instead of being in these quadrants, it will be in these. The asymptotes are still x equals 0 and y equals 0. The origin is still the center. Now, though, we are in these two quadrants. And I hope that makes sense to you. Because if you're going to multiply two numbers and get a negative, what do you know about the two numbers you're multiplying? One is positive and one is negative, right? Isn't that how we get a -4? Where do you think your vertices are? -2, 2, 2, -2. Perfect. Where do you think your foci are? -2√2, 2√2, and 2√2, -2√2. How do we get our foci? We just multiply our vertices by √2. And one more. The question always comes up, oh my gosh, Mrs. Ford, what do we do? We have something like this. Nothing different. Everything's the same. Where are your asymptotes? X equals 0, y equals 0. Where's your center? The origin. Which quadrants is this one in? 1 and 3 or 2 and 4? 1 and 3. So where are my vertices going to be? Exactly, √6, √6, and -√6, -√6. How did you get the 2 and the 2? You took the square root of 4. So how do we get our vertices? We take the square root of 6. What will my foci be then? Root 12. So 2√3, 2√3, the square root of 12, and -2√3. Now, like I said, full-fledged rotations, you start doing ellipses and hyperbolas and parabolas, it's a lot more complicated than this, but that's the only one I want you to worry about.
That number is 5 square root of 2. And since it's square root of 6, you can multiply.
Now,
Which equals square root of 2 times square root of 6
we're
square
gonna
root of 12.
do a little bit of review here. So two things. Get out your packet if you would. And on the back of the second page, it says brief recap. And while you're finding that, I'm going to do one problem from tonight's homework, and that's on page 673, number 13.
Mrs. Ford, when did you guys get this package?
When you were here, we got it a long, long time ago. We got it before the end of the last chapter. It was the first homework, wasn't it? Okay, so I'm looking at problem number 13 while you are finding your stuff there. And it says, write the equation of this parabola. I need for you to remember that the equation of a parabola, as we've been writing it, looks like this. Remember, there's one parenthesis squared and one parenthesis not squared. Now, the vertex of this one is at the origin, and it opens down. Okay, what does that tell me? If it opens down, it's an x squared. So this will be x minus 0 and y minus 0. You do not have to put those zeros in there. I am, because I just want to remind myself that's where the vertex coordinates go. And I have no idea what this number is. Now, you hopefully remember some stuff about this number. That number is really important. Remember, it gives us the length of the latus rectum. It tells us how far it is from the vertex to the focus and so on. Right now, I just need to find that number. It's very, very easy. Whatever that number is, just for the fun of it, I'll roll it in. I don't know what that number is. But this point has to work in that equation. Can you see where I'm going with this? I have an x and a y that must work in that equation. So if I plug in this x and this y, will I be able to figure out what that n is? Yep, so here we go. So 2 minus 0, that would be 4, equals n times negative 1. It looks like n is negative 4. So my equation is x squared equals negative 4y. Does it make sense that number turned out negative? Why? It opens down, yep. Okay, so there's a couple more in the homework like that you'll do that way. Okay, now did you find your brief recap sheet? This is review now for us. So here we go. No rotation there. So you want to be able to look at it and tell me what we've got. What do we have here? An ellipse. Let's go through that one more time to refresh our memories. We know it's an ellipse because there's two squared terms. They're added together and their coefficients are different. If we only had one squared term, we'd have a parabola. If we had two squared terms but they were subtracted, we'd have, oh lordy, two squared terms subtracted, x squared minus y squared. Hyperbola.
Parabola.
If we had two squared terms added together and they had the same coefficient, so we had a 4x squared and a 4y squared, that would be a circle.
360.
Okay, all right, so we got an ellipse. Do you remember what to do with it? Because your job is to find the center, the vertices, the foci. You gotta find all that stuff. How do we do that? Complete the square. So remember, we put our x's together and factor out the 4. And then we put our y's together. There's nothing to factor out. I'll move that 21 to the other side. Okay, is this starting to look familiar? Oh, yeah. Okay, so what completes a square here? 9. But that 9 is really a 36. What completes a square here? And that's a 1. So we have 4x plus 3 squared plus y minus 1 squared equal to 16. One more step. Divide. So we have x plus 3 squared over 4, because we're dividing by 16. Y minus 1 squared over 16 equals 1. Everybody okay? Where's my center? Negative 3, 1. You gotta admit it feels good to be back, doesn't it? Where are my vertices? Count sideways. 2, so negative 1, 1, and negative 5, 1. And then count up and down. So negative 3, 5, and negative 3, negative 3. Everybody still okay? It says I need my major and minor axis length. Okay, how long is my major axis? 8. And my minor is 4. I need my foci. Now remember, they're on the major axis. So we're going to count up and down. How far do we count? Remember how we do that? Center to focus for this guy would be the square root of 12. Remember, we subtract our denominators. Ay, folks. Let's fire up those neurons. So I'm going to start at this point right here, and I'm going to go up the square root of 12. So where would I be? Negative 3, comma, 1 plus 2 root 3. Square root of 12, 2 root 3. And this would be negative 3, 1 minus 2 root 3. What's my eccentricity? I didn't ask for it on this particular sheet, but you'll do it on your test. What's the eccentricity? Center to focus is how far? 2 root 3, square root of 12, 2 root 3. Center to vertex is how far? 4. So this one's actually root 3 over 2. What did we say? Who see? All right. Any question about that before I erase it?
Looks good.
What? All right, let's look at the next one. What do we got here? What do we got here? Well, it's not exactly the same thing. I'm going to do it the same way, but it's not exactly the same thing. This is a circle. Harry, not acceptable.
Yep.
X squared minus 4x,
Yep.
y squared minus 6y. Move the 2 over. What's going to complete the square? 4 and 9. So we have x minus 2 squared, y minus 3 squared equals 15. Now for the circle, all we need is the center and the radius. Where's the center? And what's my radius? Square root of 15. Beautiful. That one you remember. Good job. Okay. All right, let's see what we got down here at the bottom. What shape is this? How do you know it's a parabola?
Only one square.
Only one squared term, right. Now remember, these rules apply only when there's not an xy. We don't have an xy, so we're good. Now, we still need to complete the square. The good news is we only need to do it once. Instead of twice, we only need to complete the square once. So let's get the stuff where we're going to have to complete the square. Get him over here. Move everything else to the other side. Everybody okay so far? All right, what completes the square? 25. One more step. Remember what that is? Take out the h. Everybody good? All right. Where's my vertex? Negative 5, 3. Which way do I open? Well, I've heard up and right, and those are good guesses because that's a positive number. So which is it? X squared. Very good. This is an up. Remember your BFF. Y equals x squared. That's up and down. My axis of symmetry is the line where x equals negative 5. Here's my focus. How far is it from the vertex to the focus? Well, we call that P.
Oh, 4p equals.
So 4p I know equals 8. Remember this number right here is always 4p?
I remember my dad being. He's dead. Just heard about it.
So if I go up 2, my focus will be at -5, 5. Now remember, if you go up 2 to get your focus, you're going to go down 2 to get your directrix. So your directrix will be down 2. It's a line. It's the line where y equals 1. The length of the latus rectum, there I drew the picture of the latus rectum right there. The length of that segment is this number. Remember that? So if the whole thing is 8, then we'll start here at the point we know, the focus, and we'll go forward and backward 4. So if we go forward 4, we would be at -1, 5. And if we go backward 4, we'll be at -9, 5. What's the eccentricity of the parabola? It's always 1. That's an easy, if you remember it, it's always 1.
So parabola, it's always 1.
Okay? Now turn to the next page here where it says new stuff at the top. This isn't new stuff for us, it was whenever I did this sheet. And let's go ahead and write the equation of the ellipse, and then I'll stop. This will be the last thing we do. Let's write the equation of the ellipse. Which one do you want to do? 1, 2, or 3? Which one? 1? 1, I'm given all the vertices. So this is a vertex. 2, 2, -4, 2, -1, 4, and -1, 0. So here's a picture of my ellipse. And my job is to write the equation. Now, the equation of an ellipse, remember, after you get it all cleaned up, looks like this, right? What goes here? The center. So somehow you have to be able to find the center from this information. Won't the center be the midpoint of either axis or where they cross each other? So that would be the point what? -1, 2. So in the equation that will be x plus 1 and y minus 2. The denominators are like the radius numbers. So since we're going sideways, it looks like 3. This number would have to be a 9. And since we're going up and down 2, this number would have to be a 4. Hopefully that rings some bells. So I'm going to give you the rest of the period to kind of get started on your homework. This is not a time to be reading English. It is a time to get started on your homework. And remember that your papers are due Wednesday. Certainly if you have it done early, you can turn it in early.